Hi everyone, in this pre-lab video, I'm going to go over a brief theory of titration and also the pre-lab question for this week. Okay, so what we are going to do in lab this week is that you are going to determine the concentration of acetic acid in vinegar. Okay, so and then you are going to find out which one is the best buy. Okay, and the method that we're going to use is going to be titration. Titration is a technique used to determine an unknown concentration from a known concentration substance. So we are going to use burette and pipette in this lab, okay, because we need to know precise volume of your substance that you are going to determine, right? So note that the burette is going to be the one that you're going to fill in the known concentration of the substance, and the pipette would be the one that you are going to measure out the unknown concentration of the substance. Note that in the lab manual, there is a section of how to use burette, okay? So please read this ahead of time so that way you know how to set it up properly. Also note that because we are going to need to know the exact volume of the substance, so therefore make sure that when you set up the burette and when you fill in the substance, there is no air bubbles, okay? Because air bubbles take up volume, so that is going to affect your result, okay? Your lab instructor will go over how to read the burette in the, and here is the experimental setup. Okay, so you are going to set up the burette. Okay, so you are going to fill burette with titrant, which is the known concentration of the substance, and you are going to fill in Erlenmeyer flask with the analyte, which we don't know the concentration, and we want to find out the concentration. So the analyte, in order for us to know its precise volume, we are going to use the pipette. Note that your lab manual will have the use of pipette that you can read ahead of time. Okay? So the idea of titration is going to be rely on the stoichiometry between titrant and analyte. For example, if you know the mole of titrant that react, you can also relate that to the mole of analyte as well through the stoichiometric ratio, right? So once you know more of the analyte, then you can find out the volume of the analyte that you use, and at the end you can find out the concentration of the analyte, right? So when do we stop the titration? Then we are going to stop the titration at the equivalent point. Okay, so equivalent point is going to be the point where the mole of titrant is equal to the mole of the analyte. Okay, so this is when you are going to stop titration. For our lab this week, okay, so the unknown concentration would be acetic acid that present in vinegar, and the known concentration would be sodium hydroxide. Okay, so we are pretty much react the acid and base together. So the analyte would be acetic acid and the titrant would be sodium hydroxide. So therefore, you're going to fill this sodium hydroxide in the burette, and that Erlenmeyer flask would be the acid. Again, you are going to stop the titration when it's reached the equivalent point, or what we call endpoint in this case. And this is where mole of sodium hydroxide will equal to the mole of acetic acid. Note that because it's 1-to-1, so that's why I said that they are equal each other. Okay, so at this point, because you stop it, you know the initial volume, you read the final volume, so therefore you should know the total volume that used for sodium hydroxide as well, right? So if you know molarity of sodium hydroxide and volume, you should be able to find out the mole of sodium hydroxide, and that is going to equal to the mole of acetic acid. The next question is, how can we visualize the endpoint? Then the answer is that you are going to use the indicator. Okay, so we are going to add phenolphthalein into the analyte. Okay, so phenolphthalein is colorless under acidic condition. Okay, so as you see here, it's colorless. Okay, so as you're adding more of the base, the color will change to pink. You are going to stop the titration when it's changed to faint pink. If you add too much of the base, you are going to have excess amount of sodium hydroxide available, and that is going to be the point that is beyond the endpoint. You can visualize this by looking at the color. If you add too much of sodium hydroxide, you are going to observe the fuchsia color. Okay, so this is indicated you have excess amount of sodium hydroxide. Now let's take a look at how the color change. Okay, so when we talk about the endpoint, remember that these two moles are equal. So that means when they are react with each other, they are going to neutralize each other. So these two are going to transform, right? Because they are going to react. What are they going to transform to? They are going to transform to this salt and water. So that means at the end point, when you have these two moles equal to each other, they are going to cancel each other out, and they are going to convert into these two products. So that means at the end point, you no longer have an acid and base. Okay, so at the end point, there would be only the salt, sodium acetate available. Okay, and also water as well. Sodium acetate, because this is salt, so therefore it's going to be able to hydrolyze in water, separate into sodium ion and acetate ion. Sodium ion is going to be pH neutral ion, because this one will not react with water. However, acetate ion is a basic ion because it will react with water. The reason why acetate is a basic pH ion is because when it reacts with water, it's going to generate hydroxide ion. So therefore, this ion is a basic pH ion. And if you're looking at the phenolphthalein indicator, this indicator is going to change color between pH around 8 to 9. So that means in this case, since this salt is not a pH neutral salt, it's slightly basic salt. So therefore, once this salt is being produced, it's going to become more and more pink because of that. Now, what happens if you add more of sodium hydroxide beyond endpoint? Well, because sodium hydroxide is a strong base, so it's going to cause the pH of the solution to be higher than the conjugate base, right, which is this ion right here. So therefore, it's going to cause the pH to be higher than 9. So therefore, you are going to observe the fuchsia color instead of faint pink. Therefore, for this lab, you are going to try to achieve this faint pink, okay, so not the fuchsia color. So the next question is, how do we figure out the concentration of acetic acid then? Well, the answer is we are going to use mole over liter, right, to find out the molarity of acetic acid. Okay, you are going to use the volume of the vinegar to be the liter of the acetic acid. Okay, so the volume of the vinegar that you are going to measure out, you are going to use the pipette. Okay, so the pipette volume that we're going to use would be 10 milliliter. So that means in this case, you probably have to change that milliliter into liter first, right? So that volume of vinegar would be the same as volume of acetic acid. For the mole of acetic acid, we are going to rely on the stoichiometry. So in this case, we are going to use the concentration of sodium hydroxide and volume of the sodium hydroxide at endpoint, right, to calculate for the mole. This reaction is 1-to-1 ratio. So therefore, mole of acetic will equal to the mole of sodium hydroxide at the endpoint. Okay, so that means at endpoint, when we stop titration, we are going to assume that these two moles are equal to each other. To calculate for the mole of sodium hydroxide, you will need to know the concentration and also volume of sodium hydroxide at the endpoint. Okay, so molarity of sodium hydroxide will be given to you. So that's going to be reported on the bottle. And the liter of sodium hydroxide will come from the burette, right? The reading of the burette between the final versus the initial volume. Okay, so note that the unit on the burette would be in milliliter. So therefore, in this case, you will need to convert that to liter first before you plug it in to find out the mole of sodium hydroxide. Now let's take a look at PreLab question 2. This PreLab question would be similar calculation to your calculation in lab, except you are going to use acetic acid instead of hydrochloric acid. Okay, so this number 2 asks us to write out the balanced chemical equation between hydrochloric acid and sodium hydroxide. So if you swap the ion pairs for this, you're going to get sodium chloride and water. So again, everything when you is undergo chemical reaction, you need to be able to write out chemical equations. Okay, so the balanced chemical equation will allow you to pretty much see the mole-to-mole ratio, right? This balanced chemical equation tells us that hydrochloric acid and sodium hydroxide, they both react to each other in 1-to-1 ratio, which means that if you know more of sodium hydroxide, you should be able to find out more of hydrochloric acid as well when they completely neutralize each other or at the endpoint, right? If we talk about titration. So first, I'm going to go ahead, find out more of sodium hydroxide first. If we know more of sodium hydroxide, then we will know more of hydrochloric acid. And if we know more of hydrochloric acid, then we can find out molarity of hydrochloric acid. So let us first find out more of sodium hydroxide. Okay, so I'm going to use concentration of sodium hydroxide multiplied by its liter. So it's give us 0.0447 molar, which is mole per liter, right? It's giving us milliliter of sodium hydroxide, but we need to cancel liter, not milliliter. So therefore, you need to convert this milliliter to liter first. Okay, so if you do that, you're going to get 0.04550 liter. Okay, so after you check the unit, you're going to see that unit of liter cancel out. You're going to get more of sodium hydroxide at the end. And because we know that more of sodium hydroxide is in 1-to-1 ratio with hydrochloric acid, so I'm going to use this factor right here to multiply to more of sodium hydroxide. You're going to get the same more of hydrochloric acid as more of sodium hydroxide. Okay, so now because we know more of hydrochloric acid, then to find out molarity, you are going to use mole over liter. So you're going to use more of hydrochloric acid divided by liter of hydrochloric acid. But note that the volume of hydrochloric acid that is given is actually in milliliter. So therefore, you will need to change this milliliter to liter first. Okay, so change that to liter. And then at the end, you are going to get mole per liter as your final unit. Okay, so that would be the concentration of hydrochloric acid. So again, this calculation here would be similar to what you're going to do in lab, except you're going to change this hydrochloric acid into acetic acid instead, but the calculation would be similar. And you are going to find out volume of sodium hydroxide used from the different of the burette reading.